Okay, today we will continue for the seventh module, which is work measurement. This module will discuss some points, which is work measurement, what is the work measurement, and what is the benefit work measurement, and what is the techniques for the work measurements, what is the relation between work measurements and time study. This module discusses the work measurements techniques and the use of each technique. The techniques will help the analysis establish standard times. So the standard times will be determined by the work measurements or by the techniques of the work measurements, which is work sampling, stopwatch, and predetermined standard time. The objectives is enumerate and discuss the work measurement techniques, use the work measurement techniques in establishing standard times. So the benefits here in these modules to determine the standard times, which is very important in the motions and time studies, and is very important in the lines and in various working and various investments in our plans. And we also discussed before the importance of the standard times, and we said its importance is or are to determine the number of people in the lines, to determine the number of machines, to determine the bottleneck, and we have to find where is the bottleneck found and to give a proper solution in this bottleneck. And also we can determine the best investments and the selling price of the product. All these we can, or all these will be getting from the time standards. Okay, we'll continue. Work measurement. What is the work measurement? Work measurement in general is the application of techniques designed to establish the time for qualified work. This is the conditions. How can we determine the time standards? The time standards should be determined for some conditions. That means the operator should be qualified and skilled. Working should be normal base. And all the conditions should be in the normal. The results of the work measurement is standard time. Because when we define the standard time, we said the standard time is the time required to produce a product in a specific period, or the time required to produce a production in a daily or in a shift. But there is some condition which is qualified worker or operators, normal base, and another conditions we have to talk about them. Okay. Purpose of the work measurement. Work measurement can be used in investigating, reducing, and subsequently eliminating ineffective times. We have to eliminate ineffective times. The waste times we have to eliminate. That is the time during which no effective work is being performed, whatever the cause. Work measurement can provide management with a means of measuring the time taken in the performance of the operation or series of operation in such a way that an effective time is showing up and can be separated from effective time. So if we measure the work or the time need for the specific work, that means we have to eliminate the ineffective time. We have to eliminate the ineffective time and separate it from the effective time, because all the companies compete the effective time in the shift. Work measurement can be used to set standard times. This is the purpose of the work measurement, to standard or to set standard times, for carrying out the work. In the work, where the work is carried by the operators or by the machines, we have to measure the movement, we have to measure the behavior of that worker of the machine, all that recording to be established due to how can we find or measure the time standards, so that if any ineffective time does creep in later, which the ineffective time may become later or may be coming in the later. So we have to eliminate the ineffective time. It will immediately be showing up as an excess over the standard times and will thus be brought to the attention of the management. Work measurement reveals the management itself and the behavior of the workers. The use of work measurement. In the process of setting standard, it may be necessary to use work measurement. Number one, to compare the efficiency of the alternative methods, other conditions being equal, the methods which takes the least time will be the best method. It is sure that the work or the task which will take the least time or a less time will be the best method. Also, we said to balance the work of members of team. That means divide the work equally between the operators or between the workstation in association with the multiple activities chart, so that as nearly as possible each member has a task taking an equal time to perform. We said about these points. So to determine in association with the worker and machine multiple activity charts, the number of machines and operators, the number of machines and operator can run should be also equal, should be also endeavor work which can be done on the machine should be done properly. The time standards once set may be used. So we can set the time standards on the machine by measuring the work, In the process of setting standard, it may be necessary to use the work measurement also to provide the basis for production planning and control for the choice of the better layout. We said about these points, and for the process plannings and establishing just-in-time inventory control system. We also talk about just-in-time. To provide information that can enable estimates to be made for tender selling price and delivery dates. We also said about the importance of standard times to forecasting selling price of the product and the delivery dates for the products to the customers. To set standards of machine utilization and labor performance which can be used for any of the above purposes and as a basis of incentive schemes. To provide information for labor cost controls and enable standard costs to be fixed and maintained. Steps of work measurements. We have steps for work measurements. First, select the work to be studied. That means select a specific task. What is the specific task? We have to select first one. Second, record all the relevant data relating to the circumstances in which the work is being done, the methods and the elements of the activities in them. After that, we have to record all the data relating to the all the circumstances and the work being done. Third, examine the recorded data and the detailed breakdown critically to ensure that the most effective methods and motion are being used and that unproductive and foreign elements are separated from the productive elements. Then the third point, we have to concentrate on the most effective methods. What is the effective methods that enable us to calculate or to determine the time studies? And we have also to separate the unproductive and any element or foreign element from the productive elements. Measure the quantity of work involved in each element. Measure the quantity of work involved in each element in terms of time. Then we have to determine, we have to calculate the time which is required for performing the task. Using the appropriate work measurement techniques, we have used to appropriate techniques for measuring the work, which is observations, stopwatch, and etc. Compile the standard time for operation, which will include time allowances to cover relaxation, personal needs, etc. We have to calculate the standard times, and we add some waste time or some allowances, that is to covering the relaxation and also to cover the performance of the operators or machines. Define precisely the series of activities and methods of operation for which the time has been compiled and issue the time as standard for activities and methods specified. This is the final points, which is the purposing of the measuring measurement or the measuring work to set the standard time for the activities and methods specified. The following ways can be used to measure and establish standard times. Number one, work sampling, which depends on the observations of the movement or the work behavior. Second, time study, then standard data, the fraction professional estimate also, and finally predetermined standard times. We have to come to all points of this. Work sampling. What is the work sampling? Work sampling is a technique used to determine the total time spent or the total time spent on a job or on a workstation. This is the work sampling. Work sampling is a technique that means observation on the work or on the operator or on the machines, how can behave to perform the task. It is defined as a method of finding the percentage occurrence of a certain activities by statistical samplings and random observations. This is the work sampling. It is a method to find the percentage occurrence of certain activities by statistical sampling or by some calculation. We will come to these points. The results of the work samplings can be used to determine the efficiency of the machines and operators. Then the results of that observation for the work or the behavior of the work can be used to calculate the efficiency of machines and the efficiency of the operator. These techniques allows the analyst to establish standard times at least cost, because finally we will determine the standard times from the work sampling or the some activities or observation, some activities on the location. The following are the advantages of the work sampling techniques. Number one, it does not require continuous observation by an analyst over a long period of time. This is the benefits of the work samplings. It does not require continuous observation. No need for continuous observation. No need for continuous observation by the analyst or by the engineer over a long period of time. The clerical time is diminished. The clerical time is diminished also. The total work hours expended by the analyst are usually much fewer. The expended time spent by the analyst is very much fewer. The operator is not subjected to long period stopwatch observation also, and crew operator can be readily studied by a single analyst. Single analyst can study a crew operator easily. Determine the observation needed. We still in the work sampling. If we take samples for the observation to determine the number of observation, then the number of observation will take us to the determination of the standard times. For example, an initial study of 100 observation, the mechanic is found out to work for the mechanic or the operator. The machine, I think the machine, it is better the machine or the operator is found to be working for 75% of the time. This is the running time, and 25 idle waste time. The confidence interval chosen is 95% with 5% margin of error. For typical application using, if we use the confidence 95 interval, which is Z sigma B or subscript B, here sigma, here Z sigma, and subscript. This is the subscript B, which is for production, or probably the Z for distribution, statistical distribution. The Z can be determined from the table at the confidence of 95, which is 1.96. This is the value of the Z. The standard error of production, can be computed as Z sigma subscript B equal the margin error, which is Z sigma B sigma b equal the level of the confidence, which is the confidence is 95. The level of the confidence of the the margin error is 5. The number of observations required can be calculated as follows. This is the Z at the confidence of 95. The Z multiply sigma equal 5. Then sigma subscript here, then sigma subscript b equal 2.55. 2.55. Okay, these laws sigma subscript b or Z sigma subscript b, if we delete this one, let us delete this one. Okay, we can compute in the proper way, which is Z corrector factor for statistical distribution or normal distribution, Z times standard deviation subscript b equal root square b, which is running time, multiply idle time or 1 minus b, divided by number of observation, and so this is the running time, which is b, and this is 1 minus b or 100 minus b, no problems, or 100 minus b, or here 100, because it is probability and probability. Here maybe sometimes take 100, no problems, because it is the probability. Here maybe 100. Here it is 100, or b multiply q. Sometimes the idle times represents by is represented by q. Okay, we can determine the n easily. Easily by the square of the two sides of the equations. We have to square this. We have to square this right side and square this to get easily the number of observation from the under of the root squares. Then the number of observation 288. Work sampling is based on probability, which is defined as the extent to which an event is likely to occur. This is the work sampling based on probability. The number of observation required can be determined using the formula, which we said previously. Sigma subscript of b, here subscript of b equals this point b time or b times q over n. Sigma b standard error of proportion, or this is p subscript, this is p, we said subscript proportion. Sigma, which is standard error. P percentage of idle time, no problem. Percentage of idle time, this is the mutual p and q. It is the two number mutuals. if this the running time, this is the idle time, and if this the idle time, this is the if this is the running time, this will be the idle time. No problem, because the summation of them are 100 or 100% or 1 and number of observation. Also here we can determine the observation from this chart or this figure. If we back to this figure, what is this figure here? Here we cannot see here properly. We can back to the slide itself. Here, this charts from these charts, we can also determine the number of observation. This is the percentage of cars, which is running time, and this is the idle time. This is the idle time. We see this is the this line represents the working time, and also this is the mutual number, which is the completance for the working time, and the middle line is represents by the error. Here we can see here error percentage occurrence, and the third line is representing the number of observation. If we take here for the example, our example previous, which is the running time for the worker or the machine 75, then we can join to the error or the margin error. Then we take this line to the third lines, which will be represented which will be representing the number of observation. Another way to determine the number of observation is the use of the homogram. This is the homogram. This is the homogram. As shown in figure, this is the figure. The number of observation can be determined by pointing at the percentage occurrence. Percentage occurrence, which is the running time, and to the error connect the points and extending to the third line, extending, which means take the line from these points, extending in the straight line to the third line, which represents the number of observation. For example, at 95 confidence level with an error, then the error will be, or margin error will be 5%. The worker has been idle for 25. This is the idle time. Then the working time is 75 of the time the worker. The number of observation can be determined easily by the pointing at 25, 75, then point at the error, which is 5%, connecting the points and extending that lines to the third line or the third column, which will give 300, or around by calculation 288. 288. It is near each other because it is observation. It is observation. Then no problem from the number or the different from the two numbers. That is by calculation, and this is by the chart. we have to obtain a frequency of observation. The frequency of the observation depends on the number of observations required and the time available to develop the data. Then the observation or the frequency of the observation depends on the number of observation and the time available to develop the data. Then we need a time, and by the time we can define or we can determine the observations, then we can calculate the frequency. The observer will take the study for 15 working days. This is the times. The frequency of the observation, from these times we can monitor the observation, or we can monitor the worker and machine to obtain the number of observation. From the number of observation and the time or the period of that observation, from this we can determine the frequency by dividing the number of observation by a period, or by 15 days, which we need to determine the number of the observation, and we will get the number of frequency, or the frequency, which will be 19 observation per day. 19 observation per day. By 15 days we will get the number of observation, which will 288.